Uh, in 13.5, we sort of need to get to a point now where we're able to look at an equation and know what it is we're going to do. So let's just sort of go through some techniques. So for solving equations. Step one, a good step one would be clearing fractions if there's any. Clear fractions. We don't like fractions, right? So by multiplying by the least common denominator, that should work. So we're gonna, by multiplying by the LCD. All right, once the fractions are gone, if it's just x to the first, we just need to get x alone. If it's absolute value or square root, get that alone. But if it's an x squared equation after we get rid of the fractions, then we need to either use completing the square. Actually, we should first look for factoring, right? Factoring is definitely easier than completing the square. So we could factor, we could complete the square, we could use quadratic formula, really, if it's just x squared and there's no x term, we could use the square root property, but that's sort of, I'm gonna call that under completing the square as well. So we need to be on the lookout for what it is we're doing. So getting rid of fractions should always be sort of a strategy. Then if it's just x to the first, if there's no x squared, then the goal is just to get x alone. If there's absolute values or square roots, we need to get that alone. If it's an x squared, we got sort of 3 different ways that we've learned how to solve quadratic equations. So let's see if just these short steps can get us through the equations on this page. First one, I see an absolute value. And notice that absolute value is already by itself. So I got the absolute value by itself, alone on one side of the equation. So then we always need to split into a positive side and a negative side. Absolute value makes that V shape and typically has 2 solutions. So let's do that. We have positive or we have negative. And because the fractional part is inside the absolute value, I'm gonna wait until I do this split to deal with the fraction. So the positive would just be 2x minus 1 over 3 equals 3. The negative is 2x minus 1 over 3 equals negative 3. It's what's outside the absolute value on the other side of the equation that we're making positive or negative. In both cases, I'm going to multiply both sides by 3 to get that fraction out of there. So I get 2x minus 1 equals 9, or on this side it's going to be 2x minus 1 equals negative 9 when I multiply both sides by 3. Add 1, 2x is 10, which makes x equal 5. Or here, if I add 1, 2x is negative 8, which would be x is negative 4. So our 2 solutions are 5 and negative 4. And of course, you could check by plugging them in. I'm definitely going to run out of room if I check all these. So I'm going to leave that for you all to do. Or you could even do it in your head, right? Or just type on the calculator. Checking doesn't have to be a big ordeal, but it's a good thing to do. All right, well, that one wasn't so bad. Absolute value split into positive and negative. Great. Part B, I see fractions. So we need to multiply both sides by the least common denominator, which here would just be 6. So LCD equals 6. So I need to multiply every term on both sides of the equation by 6. And this is really like a 6/1 when we're talking about the fractions. X over 6 times 6/1. With the 3 on the left side, you could also call it 6/1, but it doesn't really make a difference when it's not a fraction. But make sure you're thinking about this 6 as being in the top, because the whole point of this is to get the denominators to cancel. This 3 goes into 6 twice. So what I end up with is 18 equals 2x plus x. 18 equals 3x, divide by 3, so 6 is x. So after we got rid of the fractions, we ended up with just an x to the first power equation, a linear equation, which means you just get x alone, right? I just had to divide both sides by 3, x is alone, we're done. If there had been an x squared, then that would be a whole nother procedure. And that is what we're gonna see in part C. In part C, we got an x squared. So we got some options. What we don't want to do is just square root both sides, because that would just make a square root of x on this side. And it looks like a square root of a negative. It's all messy. So what's going to be better to do is to add that 9x to both sides. So that gives me x squared plus 9x equals 0. When you have x squared, typically a good idea is to get 0 on one side. We don't want to necessarily get the variable by itself. We want to get 0 on one side of the equation so that we can see if it factors. So that's the next step, is factor if possible. If not possible, well then it's complete the square or quadratic formula. Luckily, we can factor this one. It'd be x times x plus 9. All right, there's a GCF, a greatest common factor of x, and you can always check factoring by multiplying out. Looks good. This has two different solutions, either x equals 0 or x plus 9 equals 0. So that would be x is negative 9. So we get two answers, 0 or negative 9. And again, you can always check by plugging into the original equation. So with an x squared in an equation, get 0 on one side and then try to factor, and if that doesn't work, then use one of the other strategies we've learned. All right, part D, we're just trying different equations, seeing what the strategy is. This one has an absolute value, but before we can solve an absolute value, we have to get it alone on one side. So we have to get the absolute value alone on one side first. It's not going to work to solve this at this step. We have to do the subtracting 6 from both sides. Then we get absolute value of 8x plus 1 equals negative 2. Does anyone see anything weird with this? That's a no solution. Absolute value cannot equal a negative. So anytime we get absolute value equals negative, we're just done with the whole problem. There is no x value that would make this true. Normally with an absolute value, we split into positive and negative. But if it already starts with absolute value equals a negative, we're just done. That was nice and easy. All right, last one is a rational equation where we know because of fractions, our goal is to clear the fractions. And to do that, we multiply every term by the LCD, least common denominator. In order to find that least common denominator, though, I need to factor this. Another thing I want to point out, there's a negative sign here. It's a little hard to see because it sort of blends in with the fraction. That's a negative. I'm going to make sure I remember it. So I need to try to factor this quadratic. So we're looking for two numbers that multiply to negative 15 and add to negative 2. That would be negative 5 and positive 3. Those would add to negative 2. So this would be x minus 5, x plus 3. Oh, and look, it just so happens those are the two denominators over here. Not really a coincidence. So what I need to multiply everything by is this LCD. Both x minus 5 and x plus 3. So let's do it. 1 over x minus 5. I am multiplying that by my least common denominator, x minus 5, x plus 3. And again, I'm multiplying that in the top of the fraction. So if it helps, put it over 1. Plus 1 over x plus 3. And I'm multiplying by that least common denominator, x minus 5, x plus 3 over 1. Equals that negative. I'm not going to lose it. You know what? I'm going to put that negative with the 7. That helps me. I like putting my negatives in my numerator. So negative 7 over x minus 5 times x plus 3, because I factored that denominator, times x minus 5 times x plus 3 over 1. Now, the reason we did all this is because now every fraction should cancel. X minus 5 cancels. Every denominator should say. So x plus 3 cancels with the x plus 3 in the top. On the right side, both factors in the denominator cancel. So now we just got to figure out what's left. In this first term, all that's left is x plus 3. In this second term, all that's left is x minus 5. And over here, the denominator completely canceled, so all that's left is a negative 7. So that's the beauty of multiplying by the least common denominator, is if you have fractions in your original equation, get rid of them, for sure. And now all it is 2x minus 2 equals negative 7. That's an algebra 1 kind of problem. I add 2 to both sides. 2x is negative 5. No big deal that I get a fraction. So x is negative 5 halves.